In this lecture, we are going to learn about halogenation of alkanes, Markownikoff's rule, Antimarkownikoff's rule, preparation of alkyl halides.
Now, how can we prepare alkyl halides? Imagine yourself that you are in a lab and you have to make alkyl halide. As a result, by adding different reagents and chemicals, and you have to bring out alkyl halides as your answer or your result or your end product. So how will you do that? Or what are the different type of reactions taking place when we add different chemicals in order to get the end product as alkyl halide? I will show you a quick tip or trick how to do that. Now, first method of preparation of alkyl halide is halogenation of alkanes. What do you mean by halogenation? Halogenation, it means addition of halogen to what? To alkenes. So simply there is a formula you must remember, that when we have our alkane and we add a halogen group, what happens is we get alkyl halide. But since it has only one halogen group, where is the H atom belonging to alkane and one halogen atom go? That would be our byproduct, that would be HX or hydrohalide. Let us see some examples. I told you recently, this is the third or second time this reaction is occurring here. So I told you X means halogen and R means alkane, R or RH, whatever. Let us take an example with CH3, simply CH4, so CH3 and H plus X2. So we will take, for example, chlorine as our halogen group. Then what will happen? This hydrogen group goes and takes place of one halogen atom, and this one halogen atom goes and take the place of hydrogen atom. So what we will get? CH3, and due to it is written here X, so we will write here chlorine. So this would be our methyl chloride. But what would be the byproduct? Byproduct would be H and Cl, hydrochloride. You can take various other bromine also. You can take bromine. So here we will get CH3Br or methyl bromide. Or HBr, whatever, and you can carry out the same experiment by taking halogen group as iodine also. But we cannot use fluorine. Why? Because fluorine is more corrosive and cannot be used in laboratory conditions. That's why there would be rarely or no reactions you will see where we are adding fluorine into the reaction in this chapter, because they are very corrosive. Alkyl halides from alkenes. Suppose we are given just this question, how will you decipher what you have to add? You know that you have to prepare alkyl halide or something which is of formula Rx, correct? This is your result. Then from alkene, that means you are adding alkene with something and you are getting your end result. Alkene, formula of alkene is basically, this is for symmetrical alkene, and we will get Rx or our alkane group. So it would change to RCH, the double bond goes away, and alkyl halide, this is just the alkane group, so we are needed to add HX to make it alkyl halide. That means we are needed to add HX in the reaction also. So that is how you can prepare. If we take an example of ethene, for example, and we take ethene, it has 2 carbon atom, double bond, CH2, CH2. We take a halogen as halogen group as chlorine. So we will get R would remain same. C, there are 2 S atom, there is double bond here. Again there are 2 S atom, we are adding HCl. What happens? This chlorine gets replaced by this H atom, is CH, CH, here one H, Cl, and you have to balance out it like H and H. So in all, this chlorine gets attached to here. Here this bond breaks up and this bond get converted into an H atom, so that becomes CH3. So that would be CH3 bond. This would be CH, CH2, CH. So that is how we can construct alkyl halide from alkene. This is for symmetrical alkene, where the alkenes, when we see this side and this side, both are equal. So that this is for symmetrical alkene. The statement says that when an unsymmetrical alkene, so we have to construct an alkene as in there would be double bond in between, unsymmetrical. So we cannot take R and R on both the sides. It would be on only one side. So this would be the one side where I am attaching my R, CH and CH2. This is our unsymmetrical alkene. When an unsymmetrical alkene is treated with an unsymmetrical reagent such as HX or hydrohalide, we get alkyl halide as a result, and its formula is CH will remain as it is. What will happen is this double bond will break up and this one H atom will get attached to CH2, so this will become CH3. R will remain as it is and our halogen group gets attached here. So what is changed? I have marked it in red here so that you can know only this much part has changed, rest is the same as it is. So we let us revise. When an unsymmetrical alkene is treated with an unsymmetrical reagent like HX, the negative part of the reagent, that means the H, gets attached to that unsaturated carbon atom which has least amount of hydrogen atom. So since it has only one hydrogen atom and this has two, so this in Markownikoff rule, the halogen atom will get attached to this carbon atom which has least number of hydrogen atoms. Let us take an example. If we take propene, let us take propene. Three carbon atom, HX. What will happen? Same, CH3. CH remains same, only this double bond get converted into single bond. double bond breaks up and becomes CH3, and our we will take here as HBr, and so our bromine gets attached to this. So this is our example. Now in Antimarkownikoff rules, anti means against, something which is not following the Markownikoff rules. It would be little bit different. The statement would be little bit different, though it has alkene only in its constituent, and also unsymmetrical reagent is also added, but the product which we will get and the halogen group where it is getting attached would be different. So that means, as the statement says, when an unsymmetrical alkyl is treated with an unsymmetrical reagent, the negative part of the reagent, that is X, gets attached to that carbon atom which has more number of hydrogen atom. Here it was getting attached to carbon atom which has less number of hydrogen atom. Here it is getting attached to the carbon atom which has more number of hydrogen atom. So it will get attached to this. So let us write the formula.
Sorry, the feed of the Antimarkownikoff rule went somewhere, so we will continue from here. Here you can see our reaction alkane, and this is the reagent we are taking. So what happens here, the halogen group gets attached to that carbon atom which has more number of carbon atom here, as it is Antimarkownikoff's rule. So what will happen, we will get RCH CH2, here X, then what happens to this H atom is, this will get attached to CH and it will become CH2. So we will get here CH2 and here CH2X. If we take an example, suppose we are taking an example of propene, what will happen, this Br will get attached to that carbon atom which has more number of H atom, which is CH2 here, and this H will get attached to CH. So we will get CH3 as it is, and CH2 Br, which is an propyl bromide. Now we are going to see different type of reactions taking place. Preparing alkanes, from now on we will see by various reagents or chemicals, using them how alkanes can be prepared. First is with the help of hydrobromic acid or hydroiodic acid or general HX, hydrohalide. So what will happen is, we know that we are going to react HBr suppose, and we will add NaBr or H2SO4. We will get alkyl halide, that means RBr. So that means we need to get R here. What we will do, we will react this with alcohol. This will be as a byproduct H2O, and we will get RBr. You can take various examples for this. Suppose if I take methyl alcohol and I put HBr in same reagents, I will get again these two will be byproduct, and I will get CH3Br, which is methyl bromide. You have to write the names. I don't have space, so I am not writing, but do remember that you have to name each and everything, otherwise your marks will be deducted and you have to explain it in one sentence each. Please do remember this. Like when we reflux alcohol with hydrobromic acid in presence of NaBr or H2SO4, we get alkyl bromide and water is a byproduct. Next is PCl3. Again alcohol, we will put PCl3, then treat it in, we will reflux it or heat it. What we will get? We need to get RCl here. First we will balance out. We know that here 3 chlorine are there, so we will add 3 here. So that means with 3 chlorine, when we are multiplying 3 with chlorine, it is getting multiplied with R also, so we will add 3 here also. So that means now it is balanced. That means 3R and 3Cl are used up. What is remaining? 3H, 3O and 3H and P. So that will be H3PO3. If you take an example, suppose I am taking C2H5OH plus PCl3, reflux or heat, I will get C2H5 Cl plus H3PO3, and for balancing 3 here, so 3 here also. For phosphorus pentachloride, again alcohol plus PCl5 in presence of P plus X2, we will get Rx. When we got R here, NX here, we got RCl. What is remaining? OH, PCl4. What we can get? HCl. So that means here we will get then we will get HCl plus what will be remaining? POCl3. Again, if we take example, let us take of methyl alcohol plus PCl5 in presence of P plus X2, we get C2H5Cl plus HCl plus POCl3.
For SOCl2 or thionyl chloride, again we will react our alcohol with SOCl2. We know that, and we will add pyridine or reflux. We know that we are going to get RCl or alkyl chloride. What else? When this is used, one Cl from here is used. What we get remaining? SOCl and OH. What we can form more? HCl. Now what else? HCl. SO2. HCl as a gaseous state and SO2. So that is how you can do reactions in this chapter. I have written some reagents with whom we will react alkyl halides. Now first is given with alkali or aqueous, KOH or NaOH. So what happens is, when we react our alkyl halide, basic formula is Rx, with, suppose we are taking NaOH. Let us see what happens. And we boil. As you can see here, there is a complex formed here, NaX, and ROH, alcohol will be formed, or alcohol would be formed. So alcohol is the main product and NaX is the byproduct. You can replace it with different type of alkane groups. Suppose if I take methyl, and in case of halogen group I take CH3Br plus NaOH. Same reaction, we will get CH3OH or methyl alcohol plus NaBr or sodium bromide. So I am just writing down the basic formulas. Now with moist silver oxide, when we react moist silver oxide, formula of silver oxide is silver oxide, AgOH. So when we react our alkyl halide with moist silver oxide they undergo hydrolysis. You can see here again a complex will be formed here, AgX and ROH. So you can again replace R with any alkane group, alkyl group, and X with any chosen halogen group except fluoride. With alcoholic KCN, Rx plus KC triple bond N. Remember the formula here. So what will happen? Compound will be formed between K and X, and rest all will react with each other or will be formed with each other. RC R plus KX, or KCN is alcoholic KCN, potassium cyanide, and we will get alkyl cyanide. With AgCN, this is also known as carbylamine reaction. AgCN means silver cyanide. So let us see the reaction. See here again, a complex is formed between Ag and X. So what is remaining? RCN or alkyl cyanide plus AgX or silver halide. Now with alcoholic ammonia, formula of ammonia we know that NH3, but for reactive part we will write it down as NH2H. So we know that alkyl halide with HNH2 heated at 373 Kelvin under pressure, we will get, see again, a complex will be formed between H and X and RNH2, or alkyl amine will be formed. Now this one, you can take various examples. If I replace R with I will get CH3NH2 or methylamine plus HCl, hydrochloric acid. Now this one, reaction with sodium alkoxide or Williamson synthesis. This is important synthesis. It gets asked into the reaction, or it is simple. The formula, we boil it and we will get ether. How? See, this compound will be formed together, NaX or sodium halide, and remaining is ether. But see, here it is written R and here also R. That means this is for symmetry. This is simple ether because both the groups attach. Suppose if I take methyl here and suppose Br plus Na CH3, so I will get that is simple ether where both the alkane group or both the R are same. But there can be reactions where both the R's are different. So I will write down the formula as by simply adding R dash here. That means one is different and another one is different. So I will just write it down here. Suppose I take this, so it would be mixed type of ether. You can remember this formula by a mnemonic like William ROR, roar. William roars. There is a boy who is named William, and he gets very angry, so he roars. So see, for Grignard reagent, the statement says that when a dry alkyl halides react with dry and divalent magnesium ion in presence of dry ether, we get Grignard's reagent. How you can remember this? I have written a quick mnemonic here that Grignard did the magic, or MGX, somewhat magic. It resembles magic, so you can remember this formula by this. Suppose if I replace it by ethane, C2H5Br, or ethyl bromide plus magnesium ion in presence of dry ether, I get C2H5MgBr, or Grignard reagent. Hey, thank you for watching the video. If you like the video, don't forget to comment, like and subscribe. And if any doubt, you can email us at the given email address below. Bye.